Okay, number 2. What is the total number of kilojoules, right? So we're talking about joules. That means we're looking for heat required to boil. So that means we know that we're using heat of vaporization. So we can cross out heat of fusion. 100 grams of water, so that's our mass. And we know that we're talking about water, so we're going to go over here and look at our heat of vaporization, which is 2260. And that is joules per gram, so we know that we have to convert to kilojoules once we're done. I mean, to joules. We're going to have joules, we have to need to convert to kilojoules. Okay, so joules per gram. Now we just plug it in. X equals 100 times 2260. That will give me X is equal to, right? And this is joules, right? So the question is asking us for kilojoules. So in order for us to get to joules to kilojoules, we just need to divide by 1,000. And like I said, I always do this. 1, 2, 3. Okay, equals 226 kilojoules. Number 3. So the heat of fusion of a compound. Okay, great. So it's just straight up telling us in this one. Heat of fusion in a compound is 126 joules per gram. What is the total number of joules of heat, right? So good, that's our X. That must be absorbed, so now we know that it is an endothermic reaction, by a 15 gram, there you go, 15 gram. So I have X is equal to 15 times 126, and I don't have the answers pulled up. Oh wait, yes I do. That would be 1,890 joules. Okay, number 4. At 1 atmosphere of pressure, not useful in this question. They like to give you lots of useless information. 25 grams. 25 grams. At its normal boiling point, again, we don't care about the boiling point because we don't have temperature in these kinds of questions, is converted to a gas by, converted to a gas. That's a big thing here. So if we're going from a gas, or we're turning into a gas, that means we must be a liquid. Liquid to gas is heat of vaporization. Oh, well, it's asking us for that. Okay. Heat of vaporization is going to be our X, and it's saying that you're adding 34,400 joules. Okay, so we have 34